So, we're going to start to talk about what is the collision reaction theory. And there's 5 parts to the collision reaction theory. And the first part, and most of them are very simple to understand. And the first part just talks about how every chemical sample or entity has kinetic energy, in which each compound or element is in constant motion. And that's the whole idea, that they can roll, they can jump, they can swirl, but every atom is constantly, or ion, or molecule, is constantly moving. And in random motion. That's number 1. Number 2 says a chemical reaction must involve the collision of reactants. So, when we have our reaction, our reactants must collide in order to have a reaction / make products. And that's the whole idea, that in order for any reaction to occur, reactants must collide with each other. Number 3 is, when they collide, they must have, when collided, they must have sufficient energy. And we'll get into that with the activated complex. And that's this whole idea, that this idea of when we draw an EP diagram, we have a reactants, and they must have a sufficient amount of energy, this kind of peak, even if it's endo or exo. So activated complex and then either decide if it's endo, so that would be above our reactants, that'd be endo products, or be exo products. So that's just if it's an endo reaction or exo reaction. Regardless, either way, you must have a sufficient amount of energy, and that is called this activated complex. And we'll get into this idea. And you can't calculate how much the activated energy is, this activated complex, but the whole idea is from your reactants to your activated complex is your activated energy. Hopefully you guys can see that. Number 4 says, an effective collision also requires the correct orientation of colliding entities so that bonds can be broken and new bonds can be formed. So, in every reaction, not only do the reactants must collide, they must also collide with a sufficient amount of energy, but also, even more, need to be oriented a specific way. And how I always explain that is if we have a puzzle piece, right? Let's just draw a simple puzzle piece. And we got this guy, and they match. And we have to connect these two together. And if they were already together, in order to break the bonds, we would have to put energy into breaking or assembling the compound. Because either way, if you're trying to take away a puzzle, you would have to have energy. To put the puzzle pieces together, you would also have to have energy. And that is this idea of the activated complex. Would the energy be going towards the products or away from the products is the idea of endo or exo. Exo being energy more so released or energy more so absorbed. Because either way, they must have energy. Like in an exo reaction, just because we're decreasing or having a negative sign, and this would be positive for endo, they still need this activated complex. Can't stress that enough. With a puzzle piece, in order to break or assemble, you must have this activated complex. Number 5 states, an ineffective collision involves entities that rebound elastically from the collision. So if that's big, if the reactants do not have sufficient energy or are not oriented properly or do not collide at all, this will involve in an elastic collision where the reactants will simply bounce off and continue in their random motion like in number 1. Now what could increase the rate of the reaction / increase the amount of successful reactions? And there are 5 things that we can do towards our manipulating our reactants in order to have more successful collisions or energy or orientation or just the amount of successful reactions. And so the first one, number 1, would be the concentration of our reactants. The more we have of anything, so if we have more shots at a goalie, the team who has more shots at any type of goalie or amount of, if you're playing hockey or soccer, the team that usually will win is the team that has the most amount of shots. That's why when you go to a hockey game, they also record the amount of shots taken at the net. Because statistically, the team who has more shots will win. So the higher the amount of concentration will lead to more success. If you have more reactants inside a solution, or if you have a solution and a solid, if you have excess of both reactants, you will be able to statistically have a better success in having a reaction. Another thing you can do to not only increase the concentration, but increase with, if you're trying to dissolve salt in water, and for some reason you have this excess of salt in water and you just can't dissolve no more, and it's considered concentrated, the thing that sometimes you might do as a chemist is increase the temperature of the reactants. The more EK, or I'm just putting in box, kinetic energy of a system, this will lead to a higher amount of collisions. If you increase the temperature of any kind of solution and has some kind of excess inside of it, you will lead for, if the molecules can start spinning around and jumping more instead of just vibrating, you have more space for, say, the salt to jump in those spaces so that everything will get dissolved and the reaction will occur. So another thing is pressure. So kind of like temperature, if you increase the pressure, you will also lead in more successful collisions with a higher amount of pressure inside a canister. So we're talking more about a gas, and how we usually increase the pressure is usually by increasing the temperature, and they're kind of both connected. Or using a gas that has statistically a higher pressure. The surface area, can you guys still see? Higher the surface area, will also lead to higher reaction rates. And all reaction rates mean is that more successful reactions. And so this higher surface area, just like going back to the hockey idea, if the net increases in size, your ability to make this soccer ball, other words known as a reactant, to combine with the soccer net, which is also another element, if you try to combine the two, if the soccer ball might need to decrease and the net might need to increase, and therefore they can try to fit easier. And you could also see the goalie as being this obstacle that you might have to overcome, kind of like the activated complex, right? And number 5 is the whole naming of this chapter, of chapter 12, is catalysts. If you add a catalyst, a specific catalyst to a reaction or reactants, not really a reaction, you will be able to decrease the activated complex. So what happens when you add a catalyst to reactants is sometimes reactants aren't naturally able to have the reaction without, say, heat or surface area or whatever their problem is happening. And if they don't have a sufficient amount of energy, what will happen along with industry is they will try to find some kind of specific catalyst that will help the reaction to occur. And so sometimes reactions cannot have that perfect puzzle piece that match, or they just don't have the energy to push the puzzle piece together. And by adding a catalyst, you will need a little amount of energy. And that's kind of drawn on page 437. So if you're to think of the red being two reactants on page 537, what is happening is these two reactants, these red puzzle pieces, cannot easily collide. And so what is happening is this catalyst, or this enzyme, this is biology, so enzymes are biological and catalysts for a body. And so it takes our two puzzle pieces and helps it guide them to combine and have a perfect reaction, and without affecting the product. So you see how this yellow is being the catalyst, is being added to these two reactants. However, when you have your final product, the yellow is not part of the product at all. And this is the idea of the catalyst does not affect the products, or it only affects the reaction in helping it orientate, having a effective collision. So an effective amount of energy and collide. So that's just kind of that idea. So the next idea we're going to go and get into is bond energy, and that is found on page 532. And bond energy is the amount of energy required to break a chemical bond, which kind of revolves around the idea of the activated complex, in which you must hit this bond energy amount for this chemical bond, because each chemical bond has a different amount of energy needed to get that reaction to occur. Similar to gasoline, why you can't smoke or have a spark near gasoline is that little spark can allow for the oxygen to react with the gasoline, causing that flame or reaction, right? That flame helps it to have that reaction. That little bit of energy from the fire or the spark allows for that energy to go.